Okay, so our first video of the year is going to be looking at something called set theory. Now, sets in English, what I'll do for each of these new terms, I'll put them in the German underneath. So hopefully this will come out in green. So, okay, apparently not. Let's try and put it in green now. There we go. So a set, we have the German word underneath now. A set is a menu. So, in set theory, sets are just looking at grouping numbers. So a set, in the loosest definition of a set, it's a group of numbers. So a set is a group of numbers. That belong together in some way. So, as an example, let's take the set A with elements 1, 3, 5, and 7. So A is a set. 1, 3, 5, and 7 are the elements of that set. And you'll notice that the elements of the set are broken up with commas, and the set is contained within these curly brackets. I'll show you how to do them up here. You kind of write a long S, and then you do the same underneath, but it's kind of like there's a mirror here. And then you do a backwards S, and then you mirror it underneath. So these are the set notation curly brackets that you have. So, to denote that something is an element of a set, we can write 1 is an element of A. So we have this symbol is the element symbol. So we can read this as is an element of. Or you can read it 1 is in the set A. That's fine. What about a different number though? What about 2? Well, 2 is not listed in the elements of set A, so we draw this kind of funny E symbol with a line through it. So this symbol with a line is not an element of. So 1 is an element of A, and 2 is not an element of A. A has 4 elements in total, and it creates a set A. So, we've got some sets that are used quite often in mathematics that I'd like to introduce you to. So let me move to the next slide. So we have some important sets. And I apologise for my handwriting on this video. So, hopefully you'll be familiar with this one. We have a capital N with a double line across this part here. This is the set of natural numbers. And these really are all of our counting numbers. So we have, for example, the numbers 0, 1, 2, 3, 4, etc., are all elements of the set N, the set of natural numbers. So this is the counting numbers starting from 0. And you'll notice that they're all positive numbers. Next up, we have the set Z, with a double line here. This is known as the set of integers. And these are all of the whole numbers, including all of the negative whole numbers. So the set of integers includes, for example, -3, -2, -1, 0, and all of the positive whole numbers, 1, 2, 3, etc., etc. And of these two sets, we also have special subsets. So we have n star, which can be written mathematically like this. This line here means without. So this is the set of natural numbers without 0. So this would then be 1, 2, 3, etc., etc. And in the same vein, we have z star, which is the set of integers without 0. So -2, -1, 1, 2, 3, 4, etc., etc. So the set of integers without 0. We have two more sets I'd like to have a look at that are important sets, both denoted by capital letters. You might be able to remember them from things you've learnt before. We have Q. This is the set of rational numbers. And this is the set of numbers, so we have every number that can be written as a fraction. And you'll remember from when we talked about fractions in class, this fraction, they can be written as a terminating or recurring decimal. So any number that can be written as a fraction, or if the number could be written as a terminating decimal or a recurring decimal, that can also be written as a fraction. And so either of those fit into set Q. And we have a really nice mathematical way of defining this set. We could have Q is equal to the set of all numbers z over n such that z is in z and n is in n star. Now let's take a moment to have a look at this a little more closely. So we have our set brackets, so we know Q is a set. And it's a set of all of these fractions. This line means such that. And I'll write underneath the German as it's defined in your book. Z is an element of the integers, so we can have any positive or negative number we like, including 0 up here. This symbol here means and. And it might be a symbol you've seen before, but it might not be. But that's okay. We have two such symbols. This one means and this one means or. But at the moment we have and. So the requirements for these numbers are that z has to be an integer and n down here has to be a natural number. So it can be 1, 2, 3, 4, 5. But we have this little star here, which means it can't be 0. And that, of course, is clear, because otherwise, if n were allowed to be 0, we'd have a number divided by 0, which is mathematically impossible. So that has to be part of the definition. So this is a mathematical way of defining Q. Our final set of numbers is R. And this is the set of all real numbers. And this includes any number you can think of. So it includes not only our positive whole numbers like 1, 2, it also includes 0, it includes negative numbers, it includes fractions, it includes even those ones that can't be written as fractions. And in your old school you should have met some of these. So for example, pi. It includes pi. It includes the square root of 2, which can't be written as a fraction either. It includes any number you can think of. Will fit into R. It's the set of all real numbers. So now we've met our sets, let's have a look at some set notation. Our first bit of set notation is, it's like a long C with a line under it. And this can be read as A is a subset of B. This means all elements of A are elements of B. So all elements of A are also elements of B. So if you had A was the set of just numbers 1 and 2, and B was the set of numbers 1, 2, and 3, then A is a subset of B. Then A is a subset of B. This also means that A and B could be equal. All elements of A are also elements of B, means that if we had C was just the set of 1 and 2, then A is also a subset of C, even though they're equal. So it still fulfills this definition that all elements of A are also elements of B. If you don't like this case and you want to get rid of it in your definition of sets that you're working with, you can use this symbol instead. This is read as A is a proper subset of B. And I forgot to give you the German. I'll put the German here. And so you see subset is Teilmenge, and proper subset echte Teilmenge. So in the example we had before, A is a proper subset of B, because A is fully contained within B, A is a subset of B, and A is not equal to B. They're not identical. This is our formal mathematical definition of a proper subset. A is a subset of B, and A is not equal to B. So we can say from our example on the previous page, we had A, B, and C. We can say that A is not a proper subset of C, because A is equal to C. So that's subsets. And in the next video, we're going to play around with subsets a little bit with the sets that we were looking at here. If you have any questions related to the video, note them in your books. Make sure you take really good notes. So you need all of the notation, all of the English, all of the German. And I'll see you in the next video and ask any questions that you have.